In this video, we're going to learn about the idea of inverse functions. And so for our first example, we're going to take the two functions. The first one, f of x is x plus 3, and then g of x is x minus 3. So these two functions, you might think of them as formulas, but I want us to try to think of them now as like an order or a direction, something to do. The first function tells us to add 3 to whatever number we have. And the second function tells us to subtract 3 from whatever number we have. And so what I'm going to do is I'm going to say, what happens if we do one of those and then the other one right afterwards? That's composition here. Well, f circle g is f of g of x, and g of x is x minus 3. And then we go ahead and plug that in the f function, x minus 3 plus 3, and we get x here. So what this shows you is that no matter what number x you start with, if you apply the g function to it, and then afterwards apply the f function to it, at the end of the day, you are always going to get back to the number x you started with. So you may or may never have come across, I don't know, I saw this when I was a kid, like a magician trying to say, okay, pick a number, and then double it, and then add 10 to it, and then do this and that. They give you the series of steps to do, and at the end, they can guess what your number was. It's basically a really long, complicated way of doing an inverse function, to where whatever number you start with, you go through the whole bunch of operations, and at the end, they can do the inverse and figure out what you started with. So the idea of inverse is the inverse function will take whatever the function did originally and undo it, break it apart, get back to what you started with. So the formal mathematical definition is that whenever you have functions, that when you compose them and you get back to your starting x, and if you compose them in the other order and get back to your starting x, and that always works no matter what x number you have, then that means that they are inverse functions. Now with that said, not every function is going to have an inverse. That's why that magician has to ask you to do just certain things, like add 10 and so on, because he needs to make sure that whatever he does is going to have an inverse to it. Now, it turns out there's a really easy way to see whether something has an inverse. If you were to draw the graph, and I'll start with, say, a parabola here. And let's say in this parabola, let's say I told you that the output number was up here at 3. Well, if you see, there's two different points on this graph that have an output number of 3. So there's no way to go back and see what your input was. Your input could have been this number over here, or your input could have been this number on the left, and we don't know. And because we can't decide which one was where we really started from, just knowing the output, that means there's not going to be any inverse. And so what they do is they call this the horizontal line test. So if you can ever draw a horizontal line and it crosses it more than once, then it's impossible for there to be an inverse. On the other hand, if you have a graph of a function like this, and it passes the horizontal line test, because again, every horizontal line only touches it one time, well, as long as it passes it, then it turns out there's guaranteed to be an inverse. So there will be an inverse on the second picture, and there will not be on the first picture. I will say, we're not going to see it too often right now, but there are definitely times that you'll have something like the first graph here, like the parabola, and even though it fails the horizontal line test, you want to force it to have an inverse, because there are times when inverses are just so useful you want to force it. And so what will happen then is you will get rid of part of the graph. You will change so you only have a piece of the graph instead of all of it. And by erasing the left-hand side, it will then pass the horizontal line test and you can have an inverse. So sometimes we'll do that, sometimes we won't. But just keep in mind is that there are some kind of workarounds even if it fails the horizontal line test. Now the biggest, I guess, problem type of thing that you need to deal with in this section is how to find the inverse of a function. And so I gave you two examples here. And it's a step-by-step procedure. You start by getting rid of your f of x and replacing it with y, because always the output is y. But then, since we're trying to get back to where we started from, we are going to switch the input and output. Everywhere we see a y, we're going to replace it with an x. And everywhere we see an x, we're going to replace it with a y. Then we're going to go ahead and solve for y. And then once we divide here, we get y is x plus 2 over 3. And this would be your inverse function. And you can check, if you were to call that g of x, say g of x is x plus 2 over 3. And if you were to do f circle g, it's going to work out back to x. So that is in fact the inverse function there. And this is the same process you'll use for every one of these. You put your y equals, you switch your x and your y, and then you solve. This next one's going to be a bit more difficult. We put our y equals, we switch our x and our y. But then in order to solve for y, the best way to do that is to multiply by y plus 2 to get rid of the fraction. On the left-hand side, when I distribute that, I'd have xy plus 2x equal to 1. Then we want to get the y by itself, so I'll subtract the 2x. And then I will divide by x. And 1 minus 2x over x, this right here is going to be your inverse function. So again, no matter any time they ask you to find an inverse function, set y equals, switch your x and your y, and then solve for y.